So I'm going to talk about the famous Canvas API that has been mentioned several times during the day. Okay, so traditionally about the graphical capabilities of OMNeT. Traditionally we had a display string for submodules which allowed one to display the module as an icon or as a rectangle or as a circle or an oval, and give it colors and stuff like that. And this was enough for wire networks. This was originally used for wire networks. But then, as time progressed, there came wireless simulations. And then people wanted to display different things in the network graphics. So location suddenly became important. It became important to display obstacles with wireless networks. We wanted to see connectivity graphs, which nodes can hear other nodes, and feedback about transmissions, and sometimes if there are directional antennas, antenna orientation became important, things like that. And for mobile networks, the movement, one wants to see the movement trails. And some of these things can be solved with the display string approach. Like for obstacles, one can place submodules and display it with rectangles, and that provides basic visualization for them. Or for the connectivity graph, one can connect nodes using gates and links. The screenshot shows actually all the mobility framework which dynamically created connections between nodes to display wireless connectivity. And then came vehicular networks, and then wants to see a street map on the screen, the vehicle properly oriented, maybe traffic lights and vehicle indicator lights and other kind of things. And then these submodules and display strings was not really adequate. One sign is that street maps could actually be achieved, but with a little trick, like in the in the screenshot here, all the street maps are drawn with the red lights and red lines, and every line segment is actually a simple module, and it is displayed using a little hack, like exploiting a hole in the validation of display strings. So that's actually a bug. Yeah, so something had to be done. And when we make a list of what we want to visualize, we can come up with a lot of things. Okay, for background, street maps, floor maps, other things, different objects on the map or floor plan. We want feedback about the wireless transmission, we want to see connectivity graph, and we want to display various annotations on the screen or live statistics. So a lot of things. So a few months ago we started working on the Canvas API, which will become available in the next versions of OMNeT. So basically we have two concepts, Canvas and figures. So there is one Canvas instance for each compound module, and you can place figures on the canvas. And also you can create new canvases on demand additionally. So what figures are available in the current development version? So we have different versions of lines. So one straight line segment, a polyline which consists of either straight line segments or a smooth curve, arc, pi slice, oval, rectangle, which can be rounded rectangle, polygon, or smooth polygon with smooth outline, ring, image, and the path. Okay. And so what is a path? That's an interesting thing. It comes from, the name comes from SVG. It's actually an arbitrary line which can consist of straight line segments and arcs and different Bezier curves. and it can be either filled or not. So it basically allows one to draw any arbitrary closed figure. Okay, figures can be organized into hierarchy. That means you can form compound figures which move together. And the implementation now adds features like anti-aliasing and opacity. So like one can have an alpha channel in figures. One can use gradients in the new API. And one can achieve layers which can be turned on and off on demand. And that's layer functionality is achieved using tags. So one can assign tags to figures, and you can say, okay, I want to see all figures that have tag foo, but hide all the figures that have tag bar. And then, of course, one wants to rotate figures and scale them and do all kind of things. So it comes down to scaling, rotation, and skewing in 2 directions. And in the Canvas API, this will be enabled by using homogeneous transformation matrices. And so every figure has a transformation matrix. And the variables A, B, C, D basically define scaling and rotation and skewing. And it's T1, T2 that they correspond to translation in X and Y directions. And this matrix applies to the figure itself and all the subfigures, which means if you change the transformation matrix on one figure, then everything underneath it will be applied to everything underneath it too. So they will move together, scale together, rotate together. Okay, how can one create figures? There are 2 ways. Declaratively and programmatically. Declaratively, in the net file, one can use properties to create figures. This add figure property, it has a name. One can specify the type, like rectangle, text, image, stuff like that, and the properties of it. And it will be displayed automatically. Or one can also create figures programmatically from C++ code. They are like normal objects. One can create them, insert them to the canvas, and set different properties on it. And it's also possible to get hold of a figure declared in the net file. So one can also manipulate those. So there's a small demo here. So the road was drawn using a smooth polygon. Actually, it's 2 smooth polygons, because one is the road itself, and the other polygon is the paint, which is drawn in white dashed line. And the car is, of course, an image figure. There is a rotating antenna dish and transmission beam, or whatever how you want to interpret it. And then the display on the right-hand corner, it's basically a rounded rectangle with opacity and some text items. And it's controlled from C++ code, of course. So this is how I implemented it. So the figures basically are described statically in the net file. And you can see the figure hierarchy on the left-hand side. So I've got under the canvas, I've got the road and the paint on the road at the same level, and the trail, which is left behind by the car. And the car, inside the car, there's the antenna and the beam. They are child figures, so they move together. And in the status rectangle, we have the different text figures. So they are all declared statically in the net file, and what the C++ code does is just gets the pointer of those figures, and then the runtime manipulates it. For example, for the car, we always replace the transformation matrix. We rotate, the car is originally at the origin, a 0, 0 coordinate, and then we rotate it and move to the right position. And for example, for the antenna that's on top of the car, we just rotate it by a predefined angle at each step. So this was a demo, and actually this was a very short presentation. Thank you for your attention.
I just interesting that this API can connect to the Sumo.
Yes, actually you can use this API to enhance any kind of simulation. So if you use it in games, then one can draw the cars and the streets and other things that are also going in Sumo.
Oh, I think that will be cool. Because I have make a demo and put my car on the Google Earth, but this is more slow. I just can put 10 car or 20 car on the Google Earth. So we have a demo. We have a demo of the OMNeT. It's the Google Earth. So I put the OpenStreetMap on the OpenNet, and I make like a middleware and put this line on the Google Earth. So it works. And but this is more slow and not very good. So this will be good if you can link to the Sumo. This will be good. Yes.
Yes. So actually, this is just a tool. It will be. I mean, its usefulness will be determined by the users.
Yeah, so you said that everything that you put into this tool, into the canvas now is backgrounds and background graphics, right?
Yes.
So can you now also export a kind of screenshot as a vector graphic, or can you still?
No. It's up to. So the implementation is in the TKM, and the TK canvas itself, it can export PostScript. But we use, for these graphics, we use an extension of TK, which I'm not sure whether the PostScript callbacks are implemented in that library, so I don't know whether it can be.
Yeah, because it would be really nice if we could also, when you have this animation and then you want to have a high quality figure from that you could use a vector graphic.
Yes, we use an extension called TK path, and that TK extension was originally conceived to enable SVG graphics for TK, typical TK. But the project was abandoned meanwhile, but it still has quite a lot of things useful for us, even though it cannot exactly display SVG, but the elements for SVG graphics are in there. Yes?
So the example you had kind of everything within one module. It was the car demo, and then it had the car and the road and the status.
Yes.
One thing that can be hard is that if you have things from more than one module, if you want to have application elements where the application is defined some graphical things, but then you also want to take from a routing protocol or from a wireless protocol graphical elements, it's very clumsy now to try to combine them. They're different scales, they don't match, and this and that, and they get put on top of each other. Does this structure help, or what do you think?
Well, this is just the basic infrastructure for drawing, and that's another question: how one wants to build this feature into the INET framework. I can imagine that, for example, inside a host, you can put some kind of a display manager node which collects information from inside the host and puts them on the canvas, or you can have a module, a top-level module, which manages the whole display for the network, and that would collect information from everywhere in the network, and that would decide what actually makes it on the display.
So you think that perhaps in something like INET there should be some standard APIs that all of the protocols could use, so that when they all try to display things, it doesn't become, because it kind of becomes insane now.
Yeah.
You have your routing protocol displaying things and your
Yes.
transmissions displaying, and they all do it. I mean, they were all,
Yeah.
they're not scaled. I mean, even just simple things like they're not scaled to each other. It seems like having some mechanism per framework that says, okay, everybody talk to the canvas in a certain way, and then it should at least do simple things like scaling
Yeah, for INET,
in
I
some
think
useful way.
I would go for something like a public subscribe kind of thing. So the routing modules and Mac modules and all the modules, they would just publish information in form of signals, for example. And then on the top level, I would have something like a display manager, which would be very, very configurable. So you would choose which aspects it would display. So it could display, okay, the nodes, or the trajectory of the nodes, yes, no, or each transmission, yes, no, or the connectivity graph, yes, no, or last few successful transmissions, yes, no. And you would configure that. And then that would just subscribe all the signals to collect the information from everywhere in the simulation and would manage the whole display. I think that would probably be a sane approach.
Yeah, because right
And
now,
then you can-
it's quite hard, because everybody does kind of their own scaling and their own this and their own that. And so
Yeah.
you want to share both the wireless and something in the application. They just start drawing icons on top of each other, and you have to go you have to go fixing things. I think it would be nice if there was within a framework, there would be some kind of way that even if you didn't know, you have some wireless thing, you don't know what applications are going to be used with it, but you can still write it in some way that if some application wants to also display things, something sensible can happen. Because otherwise you end up just parameterizing all of the display parts for every little module you're using, and it's really good.
So I think the public supply thing would be better probably, because we would separate the thing, different concerns. So that would be code which deals with the graphics, only the graphics, and then it could be either thrown out or replaced with something else, and you would have different visualization. Another thing that we thought about just recently is that we could add, okay, a lot of people, a lot of companies use, for example, LabVIEW. They are used to LabVIEW type of interfaces. So you get a simulation, you have a few switches and knobs and levers, and you can adjust the parameters of the simulation, and you can have little meters where you can, read the packet loss rate or whatever. And so we thought that it would be probably a good idea to build some kind of widget set on top of the figures API so one can add, for example, knobs and switches to the canvas to adjust simulation parameters, and also to runtime show the simulation results while the simulation is running. So that's something for the future.
I saw something like this last year on a demonstration at a conference in Stuttgart.
Yeah.
Someone, they interfaced INET, they had INET simulations in, I have to look up the poster again. They also had a tablet just over a wireless LAN connection to the basic server where the simulation run. And they had some app running on the tablet, just adjusted, okay, basic things like simulation speed is one thing, but also the parameters, okay, number of failures, stuff like this during runtime. It was quite nice for demonstrations.
Yes.
Maybe a question not directly related to the cameras, but will there be a convenient way to zoom in and out in the simulation environment?
Yeah, we'll see that. I heard it yesterday too from I don't know who said that, but
because it's really hard, if you have a large network and you want to zoom in one scene and then out another.
It loses the center of the zoom, right? It just moves away to some different location when you zoom in and zoom out. Yeah, we just recently noticed that.
Oh. I should have told you years ago.
So my attach a canvas to some object in the simulation, kind of like the display string, saying this is represented not as an icon or as a text, but as a canvas that moves as the object is moved on the playground?
So you want to, I'm not sure I get it correctly, so you want to have a canvas which moves on another canvas? Or
Well, the thing is, I'm thinking of an easy migration path from the oldish using display streams to visually identify modules on a playground to this new canvas. I was thinking that maybe it's a good compromise to be able to just attach canvases to sub-modules, saying, okay, this host is being represented not by an icon, by specifying display string I equals whatever, but by saying this is being represented by a canvas, and then allowing this node to draw itself on the kind of parent canvas.
Well, a module can get a parameter to the parent compound module and draw on its canvas.
But then I would have probably to interview this, please tell me where I am being visualized on your playground, and tell me what your scale is, offset is, or so that might get more complicated than just OMNeT taking care of this for me.
Yes.
And I'm saying, okay, please draw me a card where I am.
I think I get what you're saying, but probably terminology is wrong because it's not called a canvas, it's called a figure. I think it's.
Oh yeah, it's a sorry.
Oh yeah.
And you say that the submodule could have a figure.
Yeah,
So
we are thinking about it, yes, that we create a special type of figure in addition to this type of figure. That would be a submodule figure, and that would be capable of doing exactly what a submodule can be.
That would be
And a submodule, yes, to display itself as a figure, yes. Yeah, definitely.
And something very general I was thinking about, it doesn't fit at all with the discussion about canvases. I was thinking about, I think that was during the INET session, about initialization. We had this parallelized INET with the initialization being very complicated. And whenever I write new modules, it feels to me like module initialization is kind of a black art, because you have to know what is being initialized in stage 3, and should I be a stage 4 initializer?
In INET, yes.
Does it make sense to migrate towards a dependency-based initialization concept?
Okay, first we have in the branch, we have a development branch of INET, which we released at 3.0. And in that version we have migrated away from these numbers, and at least we use a layer-based initialization scheme. So first the physical layer initializes itself, and then the data link layer, network layer, and so on, bottom-up order, and every layer can have two stage initialization stages, and we move the INET framework to this scheme, and it works out quite nicely. First we were thinking about using a dependency-based initialization too, but it was just a little bit too complex, and we felt that it's not yet justified. So we don't have that much complexity in the initialization yet. And this layer-based initialization scheme, it can be migrated later on to a dependency-based one if we really get to such a complexity level.
So which layer would energy be, or mobility? Just to ask me questions.
I think mobility has its own layer, somewhere at the lower layer. Energy could be the same layer as mobility, or we can assign something else. It's its own init stage to it. Yeah, there are lots of corner cases which do not clearly fit anywhere, but we could squeeze in everything. And it came out quite nicely in the beginning, so it was quite logical and clear. So we are content with it.
At least we do not have numbers in the code anymore.
That was really confusing.
Yeah.
Okay, and another question I wanted to raise was the issue of simulation, result collection, and evaluation. Because I can't be alone in just having too much data output by OMNeT to be able to process that with the R snippets that are on the website. they're rapidly becoming out of hand. So I wanted to do kind of a poll or something, what people are using for result collection and what people are using for evaluations. So I'm guessing, well, I'm not guessing at all. So my favorite is using R, dumping everything to a vector file or a scalar file and then reading that plugin, but that takes forever. Probably because I'm logging too much, but can't hurt to have more data. So I want to drill into data when I find out that there's some inconsistencies or whatever. I played around with logging to different vector files. We have some kind of low granularity vector file and high granularity that I never have to load because it's so huge. But that didn't work out so well. So yeah, what are people using? I mean, or am I alone with the problem of just logging too much data? Is anyone using SQL for logging? Is anyone logging to a database?
Well, I've tried, for instance, with log files, gigabytes of log files, instead of using the output vector. It didn't work out that well either, because now you have to use something like Python or whatever script you want to use and use GNU plot or try to move the data to MATLAB and get some nice figures. I don't know if that would be a good idea to combine with a database program like MySQL or something like this, like sending some queries. If that